Hello and welcome to Earth, Moon, and Mars, Building a Sustainable Path to Mars. I'm Joe Cassady, Executive Director for Space at Aerojet Rocketdyne and Executive Vice President of ExploreMars. And I'm excited to be moderating this panel today. We have a really excellent panel. Let me introduce you to our panel to tell you how we're going to build that path for humans to Mars in the 2030s. First up, we have Antonietta Perino. Maria is Director of the Space Economy for Exploration and International Network at Thales Alenia Space, Italy. And next we have Naoki Sato, JAXA Space Exploration Center Director for Space Exploration System Technology Unit. And finally, we have Chad Davis from Northrop Grumman. He's a Senior Manager for Human Spaceflight Integration and Operations. I would just kick this off by saying I think a lot of folks right now are a little confused as to what kind of activities are happening today. We have work going on to develop new life support systems on the ISS. We're doing a lot together, NASA, ESA, JAXA, in terms of planning the Artemis program. And I think it's hopefully today we can help you connect the dots and see how that's all getting us ready to prepare to send humans to Mars. So at this point, I'm just going to turn it over to our three panelists and let them set the stage, and then we'll come back and discuss how we're working to build that sustainable path to Mars. So let's start with you, Maria.
Thank you, Joe, and thanks for having me on this panel today. It's a pleasure to be part of this conversation with the other colleagues, and the topic is of great interest to all of us and to humankind, I would say. So I like to share with you what we in Europe, and in particular in my company, are doing to prepare this path that is going to bring humankind in the stars, starting with the orbit around the Earth, the orbit around the Moon, on the Moon surface, and finally traveling to Mars. So you mentioned, Joe, that the topic of this conversation is specifically to build a sustainable path to Mars. And we in our company like to do that, keeping an eye on the fact that we have to contribute to maintain a sustainable life on Earth. So we look at the stars, but always focus on the terrestrial needs. We start from the space station. In fact, the International Space Station is precisely the place where we learn how to permanently live and work in space. And so to build a sustainable path, we need to start precisely from the initial steps. And the International Space Station, in fact, we believe that is key to prepare and to help developing the capabilities to meet the next destination. Why that? Because we can exploit the lesson learned that we got from the in-space operation of all the International Space Station elements, pressurized modules, payloads, logistic operation, extravehicular activities. Another big help that can come from the International Space Station experience is that we can develop new technical solution to meet the new challenges to operate in Moon orbits and on the surface of Moon and Mars by improving material, by, for example, using lighter structure, by incrementing the modularity of our system. For sure, we need to then develop regenerative life support system. Also, the International Space Station is a perfect test bench where we can validate the technologies before we can plan and use them further on the Moon or on Mars. And last but not the least, the International Space Station is the place where we can develop and increase our knowledge related to the fact how can humans can live in space, and we need to understand which are the gaps in this knowledge that we need to fill to make the future mission possible. What Europe can, bring on the table, because for sure exploration is an international matter. We need to really get together and join all the capabilities that were developed by the different partners. So in Europe, we believe that we have a strong heritage related to in-orbit operation. We developed many of the elements of the International Space Station, like the nodes, the Columbus Laboratory. We developed cupola, in fact, in our company. And we perform many logistics activity. And to sustain that, we needed to develop many logistic modules like MPLM, ATV, Sinius, that is very dear to our company. And we also learn to operate scientific payloads and experiments. So I wanted to put, in these charts all together, also in a sort of visual form, this sustainable path, because for sure exploration will be, and in fact it is already, a step-by-step process. And so from the International Space Station to the Gateway, which are the logical steps? We need to exploit whenever possible the proven designs that will have to be customized to meet the new mission requirements. So, for example, from a structural point of view, we will need to size the elements to lighter target. We will need to use new materials. For example, we are working now with acrylic material for the windows. We will take benefit of the experience developed, for example, with the ATV to operate the Orion European Service Module. Obviously, we will need a new development that will be good for the new lunar harsh environment. So, new thermal system, new radiators, protection against the micrometeoroids, and so on. Another important learning point, we will have the possibility to apply the techniques that we are currently using from the International Space Station, like, for example, telerobotic operations that will be key to operate elements on the lunar surface from the Gateway, for example. We will have to master 3D printing activities, both in orbit and on the moon. We will have, for example, to take benefit of the key factor we adopted for redundancy and safety issues. And then the next step, from the Gateway toward the moon surface. So the need, the ascent, is on a more modular system, more autonomous system. We are farther away from Earth, so the elements will need to operate by themselves whenever possible. So, as said, robotic operations, different environments, but we will discuss that, I believe, when we will talk in our panel. A longer presence of people in deep space will demand new solutions for radiation, for life support, as said before, and so on. And then, next step, Moon and Mars. So moon exploration in a sustainable ways means that we will have to exploit the heritage and the capabilities that we currently know much farther away, so much farther beyond low Earth orbit. And we will carry on us the beautiful experience we learn in working in an international and cooperation environments. So for that, we will also collaborate with new players, even small companies, but with specific technologies. And so there will be the need to develop a more agile and spread supply chain. And then the last part of this slide recalls the fact that Moon can have a strong validity point as a potential prototyping place where systems, technologies, operations can be tested before we consider to, realize that on Mars. So key issues: robotic to human interaction, landing techniques, mobility on surface, protection from environment, new power system, including nuclear. There is a lot of talking, not only talking, there are many activities on this topic in these days. Habitability issues, new habitat solutions, for sure exploitation of local resources, and to better know the places where in the near future we will live and work. For sure we need to get samples, bring them back to Earth to know these new planets better.
Okay, thanks, Maria. That was a wonderful. Oh, that was a wonderful overview. And I forgot to mention earlier in her introduction that Maria is, of course, an old friend and colleague, and it's wonderful to have her today on the panel.
Thank you, John.
From Europe, let's move to Japan and hear from JAXA. So, Sato-san, would you like to share with us your thoughts?
Okay, thank you very much. I'm very pleased to be here, and I have been working for this international space exploration area for about 15 years. It was very exciting, and I hope that will be further excellent and exciting program. So I'd like to make a presentation how JAXA see the Mars exploration. Okay, this is a very informal view for the human Mars exploration. So we'd like to play roles in the human Mars mission with the key technologies, and also play key roles in its precursor mission as well, robotics missions. And we are going to demonstrate the key technology in the international lunar missions. And also, it is very important to perform the top science on Mars to contribute the advancement of human intelligence. And by those contributions, we'd like to send Japanese astronaut to Mars. Next chart, please. So I'd like to talk about what we are going to demonstrate the key technologies. Please click one more. Yes, this is the gateway. So for the gateway, Japanese government has already committed to participate in the gateway by providing the key technologies such as the habitation technologies, and also the logistics missions to the gateway. So through these missions or capabilities, we are going to demonstrate the free generative eclipse and also the health management. And for the during the logistic mission, we are going to demonstrate the autonomous rendezvous and docking technology, which is very important during the Mars mission, I believe. And for the ECRUS technologies, we are targeting the full regenerative ECRUS, but also we are targeting to reduce the consumables and the spares as much as possible, because during the Mars mission, we should make it make the spares and consumables very less volume and weight. Next chart, please. Okay, the next one is the traversing technologies and the exploration technologies. On the left-hand side, we can see the LUPEX, which is a lunar polar exploration mission. This is still under the pre-project phase. It's about to the project. In this mission, we are going to demonstrate the capabilities to search for the water and other resources, and also some technology for the science observation. So I believe these are also very important and to the Mars mission. And next, sorry, at the right-hand side, this is the traversing capabilities. As you know, we are collaborating with Toyota to develop the pressurized rover. So I believe this is very important key technology on the lunar mission and also Mars mission. Next shot, please. So the third one is the landing technologies. In the left-hand side, you can see the SLIM. This is already in the project phase, and I believe the past CDR, and it's scheduled to be launched in 2023. This SLIM mission is going to demonstrate the pinpoint landing technology and also the hazard avoidance. And we are now in the mission formulation phase for the mid-size lander, which is very bigger than SLIM lander. It's about the 10 tons, around 10 tons. And we are also enlarging the thrusters to the, maybe it's going to be a cryogenic engines. Next chart, please. So this is the last page. This is very conceptual phase, but we are also researching the ISRU technologies, such as excavation and transportation, and also extraction and electrolysis and the liquefaction, mainly to convert the water to the rocket fuel. That's all. Thank you.
Thank you, Sato-san. That was very good, and I appreciate the very thorough presentation. So now we'll come a little closer to home and come back and hear from Chad Davis at Northrop Grumman. Chad, you're on.
Thank you, Joe. Hello, as Joe said, my name's Chad Davis. I'm from Northrop Grumman. I'm a senior engineering manager at Northrop, supporting the space sector in our human explorations office. So if you could bring up my slides, please. All right. I'd like to thank everyone for the opportunity to speak at the summit and participate in the panel today. Sustainability is exactly the core behind what we're doing at Northrop Grumman on the HALO program for the Gateway. For those not familiar with HALO, it stands for Habitation and Logistics Outpost, and will be the first habitable element for the actual Gateway itself. The Gateway is a small space station that orbits the moon that provides vital support for sustainable, long-term human exploration for the lunar surface, cislunar space, and eventually deep space exploration. We're building HALO as part of NASA's Artemis program, which will land the first woman and the next man on the moon in 2024, using innovative technologies to explore more of the lunar surface than ever before and establish sustainable exploration by the end of this decade. NASA will then use the knowledge to the next giant leap of sending humans onto Mars. So next slide, please. HALO overview is very similar in conjunction with what's being built by the European Space Agency, the International HAB module, the IHAB, which will provide the temporary living quarters for the 4 astronauts who will work in cislunar space and prepare for the lunar surface missions. HALO will also provide payload accommodations, external robotic interfaces, voltage power will be regulated through the PPE to support HALO. HALO will have sustainable ECLS systems, and then of course support the logistics storage for the crew for up to a 30-day mission. HALO has 3 visiting docking ports, which will host the lander as well as the logistics vehicle and then the Orion vehicle. So initially, the primary function for HALO is to house the astronauts, to give them a place in cislunar space as they prepare for their surface visit. It supports the crew for the 30-day period, whether they be on the HALO or the return from the lunar surface. It's providing the command and control center and the data control, as well as energy management, power and energy management and thermal control, as well as communications and tracking from the HALO of activities on the lunar surface, and also acts sort of as a relay station using part of the comm system provided by the by ESA. HALO features the 3 docking ports, 2 radial, 1 axial, and those will allow for the Orion vehicle to visit, as well as I mentioned before, the logistics vehicle, the lunar lander. And once the vehicle expands, it has the IHAB attached to it, which you can see in the lower left picture. It'll serve as that axial port will serve as an interface to grow the gateway itself, as well as the radial ports have the option to add additional modules. As you can see, the Esprit refueling port on the sort of the right forward side of the HALO module. HALO will utilize critical subsystems like environmental control and life support, or known as ECLS, thermal control systems, CNDH, the computer and data handling, fault isolation detection recovery systems, EPS for the electrical power, and then of course crew systems and human systems interface, HSI, to help during this design phase for the gateway, to make sure it's a safe home for the crew once they're on board. And we'll use all that to gain our experience in cislunar space with these subsystems, because that's paramount for what the designing for the future systems that'll have to be more sustainable and independent for journeys to Mars and to the surface of the moon for extended periods, as well as to surface to Mars eventually. Next slide. So in summary, designing the HALO, the primary is understanding and maturing the technology for the life support systems, the avionics, the thermal controls to meet the 15-year life expectancy of the gateway and the HALO vehicle itself. But that's also expanding our capabilities with respects to how we maintain it and design its longevity to support long missions whenever we venture out into the deep space for missions to Mars and so forth. We're partnered with NASA to develop these technologies, and our international partners as well to help us bridge that gap. I see HALO as sort of the staging point, the train station, so to speak, that gives us the ability to step out onto the lunar surface, to learn what it's like to live a little bit further away from Earth than we have been on the ISS, and then obviously use it as a building area to build up our vehicles that'll eventually take us to Mars. So it has a a large responsibility and basically a huge stepping stone into the cosmos of what we can do in human exploration. So that concludes my slides.
Thank you, Chad. So at this point, I want to thank everyone for those very fine presentations, and I hope that our audience now has a little better idea of what we're doing now that is going to help us prepare to build the sustainable path. I'd like to kick off the discussion with just a few questions here for everybody on the panel, and you can just chime in. What are the main ways in which the moon can help us learn how to operate in a deep space environment to prepare for Mars? I think you've all mentioned some, but I guess I'd ask you maybe your top 3 or top 2. What are the things that you feel are the most important? Going to start, Maria?
Well, yeah, first of all, let me compliment the beautiful presentation by Chad, sharing a very good news with our audience. In fact, we are very proud. We've been proud for many years to collaborate with Northrop and also for ALO. In this case, we are building the primary structure and the micrometeoroid protection. So the good news, guy, is that work is in progress. We are really building HALO. And also, as Chad mentioned, we are already working at the IAB development and also ESPRI. In fact, Thales Alenia Space in Italy is prime contractor. We got the contract for IAB, and Thales Alenia Space in France got the contract for ESPRI. And so there are many ongoing activities on this topic all over the world. Sato-san also mentioned the important contribution by Japan. So coming back to your question, Joe, which are the 3 important points? My opinion, the first one is not only a technological matter, but is also a psychological, human-related matter. So for sure, Gateway and the moon will be instrumental in, how can I say, making people used to see the Earth from a certain distance. And this is not so easy because every time the astronauts are on board the space station and they miss home, they can simply go to Cupola, that is our jewel for our company, and they look outside and they see home. They can recognize features. They see rivers, mountains. So they perceive inside that they are not too far away. When they will be on the moon, the view will be different, and even more so when they will be in transit to Mars. This is one of the many reasons why we devote a lot of attention and care, really care, when we design the new habitat solutions, because we believe that it's important to carry on a sort of human-centric design approach, where the human being with his, physical and psychological needs have to really indicate the right, let me joke, the right path to Mars. And so we really want to do our best, at least to offer them a comfortable environment, given the fact that they will be, our hero, traveling for the first time so far away.
Thanks. Oh, that's wonderful. Sato-san, your thoughts, please.
Mission. There is several aspects which is more severe than Mars mission. For example, the moon doesn't have the atmosphere, so that's why I think the summer control system is a little bit difficult to design for Mars, for Moon rather than Mars.
Yeah. Mm-hmm.
So I think this is the maybe it's the best way to demonstrate on the Moon for the thermal control system, and also the night survival capability. On the Moon, the night is very long, and the such survival capability is very severe than Mars. So I believe that it's very good demonstrate the demonstration place than Mars. And for the traversing capability of technology, the Moon is very low gravity. So I believe that the low gravity is more severe than for the traversing technology. So it's very good opportunity to demonstrate such a capability on the Moon.
And so therefore you believe if we can do it on the Moon, that will translate well to traversing capability for Mars. We'll be able to pick that up and take that to Mars.
Right.
Excellent. Okay, thanks. Chad, your thoughts?
Yeah, I really follow a lot in similarity with what both of the panelists have already said from the perspective. I think the lunar exploration gives us the opportunity to really test out our systems. Obviously, the lunar regolith, the dust, it's going to be very comparable on the Mars surface, how to deal with those kind of things. The radiation environment, how we, decide what we think's rad hardening today, what that really looks like for cislunar space after we've had the gateway out there for several years of operation, as well as something near and dear, logistics, how we develop that logistical plan to support not just so many couple of hour rendezvous to a LEO vehicle, but something that takes 7 days to get to for the Moon helps us develop our strategic logistics planning so that we can really understand how that longer distance impacts the logistics and supply chain activities, because obviously it's an order of magnitude greater for Mars. So I think all of those are going to be very critical takeaways as we earn our bruises on the lunar surface, learning how to operate in that further away from home and that more harsh environment than we currently do today on the ISS.
Yeah, that's a point I wanted to pick up on. You brought up the radiation environment, and our experience to date is extremely limited with Apollo, I guess, having had only 12 people outside the Van Allen belts, right? I mean, I think that's the key thing is ISS is still down kind of under the Earth's magnetosphere, gets protected to a certain degree from the background radiation in space. So this is going to be our first chance, isn't it, to really get experience for humans, for the systems that are going to have to operate for a long time to go to Mars. And I'm sure that's part of what you all are thinking as you're developing these systems, as you described with Halo, for instance, and for the IHAB, and even the surface systems on the Moon are going to have that same issue with, long-term operation in both a harsh thermal as well as the radiation environment. So, any thoughts about how you're going to work in that radiation environment? What does that mean to the development of the systems that you're working on?
Yes, I don't know if you can show, if I can share my screen. Okay, for sure, radiation is one of the many issues we deal with for the new habitats we design for deep space. I wanted to share with you these pictures because, in fact, we are designing, how can I say, new internal layouts that can be reconfigured by the crew according to their needs and moods also. And as for radiations, we are making use of water walls. So we plan to use water and other advanced materials to try to provide the proper protection to the crew members. And yeah, we as you can see here, we also like to offer larger habitability solutions, even if the structure, the external volumes are critical because are smaller than for the space station. But thanks God, we have new technical solutions in these days. We have 3D printing, we have virtual reality, and so you see, if you compare the current internal layout of the typical International Space Station module with this type of new internal architecture, you see that there is a big step forward.
Thank you, Maria. So, Chad, both you and Sato-san have mentioned the logistics aspects of supporting lunar operations and the gateway and surface operations. Could you comment a little bit on what some of the challenges are? I know both Japan and Northrop Grumman have both supported space station logistics. Could you compare and contrast between what it takes to do that for space station and what it's going to take for us to do that out at the moon?
Chad, you go ahead.
Okay. Yeah, some of the things that I had thought about as I was thinking through it was the fact that it's really going to be a key thing that we learned through the Cygnus program. We're on the 16th mission right now up to the space station, is the flexibility in the planning with respect to the manifest, what the space station, what the crew needs, what the science that's going up to the space station and so forth. And that's one thing that our team has learned over the past several years working the CRS program, is having that flexibility to support the logistical needs of the ISS, and then working within their planning mechanism to make it all happen in a timely manner. If there's one vehicle that has a slip to the left or right, then quickly pulling cargo from one to make sure it can go on another vehicle for whatever's critical to get up to the space station in a timely manner. So it really, in my opinion, comes to the planning aspect, which, back what I said previously, I think we're going to be learning through some probably painful lessons in the beginning of cislunar operations, but the planning aspect to it is going to be critical, because you've only got potentially one logistics mission for that entire year, or potentially over a 2-year mission, depending on how the budgets work out for logistics vehicles to come to the gateway and so forth. So you've got multiple drivers. So it's going to be really developing a solid planning system that allows you to develop the manifest, to understand what you're putting on the vehicle. When we were working next step, phases 1 and 2, the precursor to the HALO program, it was a lot of research was done in understanding, what we can put on a vehicle to place out at the gateway in advance of the crew arriving. And some of the discussions, for instance, was food. And after so much time in the radiation environment, it starts losing its nutritional value and so forth. So again, planning is going to be critical to make sure that you think about those kinds of things. Sparing is another item that was mentioned earlier. Those are the kind of things that you need to think about. What particular hardware that you have to keep up with, or that have, for instance, like the ECLA system, if it has filters or other items that have to be replaced on on what you would consider a routine or regular basis to make sure you have the right sparing for those particular items. And then obviously backup equipment, critical backup equipment that were to drive the sparing as well. So again, it's really going to come down to thinking out very methodically for this deep space planning approach on how we're going to keep the logistics chain going so that it's a continual, perpetual motion to support the ongoing operations.
Sato-san, would you like to add to that?
Okay, I'd like to mention the technical aspect, technology aspect, the difference between ISS and lunar mission. So as you know, in the ISS program, we can use a GPS for the navigation system of the logistic vehicle, but for the lunar mission, we cannot use the GPS system. So we'd like to use other technologies such as range and range rate from the Earth observation or other systems such as the more long distance sensor or something like that. So these are very challenging for us. So I believe that if we have the GPS-like system around the moon, it's very beneficial for us.
So that would be a future desire if we can build up a nav system that goes all the way out into cislunar space.
Right. Yeah, it's a little bit future, but we'd like to have that very near future.
Got it. Right. No, that's a wonderful point. And I think both of you bring up something which is kind of inherent in our strategy already, which is having multiple channels. And I know, for instance, we developed the replacement batteries for the space station. Those were all taken up by the HTV through JAXA. I think primarily because their lithium-ion batteries and their external, payload capability on HTV was quite desirable instead of being in a pressurized cargo situation. As everybody knows, who's flown on an airliner, you have to be a little careful with lithium-ion batteries and putting them in the cargo holds. So it's just, those kinds of things, having the ability to use the JAXA's capabilities, the capabilities that Northrop Grumman has already developed with Cygnus and other potential partners, I guess, having multiple places. Chad, you brought up the idea that if one is a little delayed, you've got the ability to switch and make sure that those critical items get there on time. And I also thought the point you brought up was really good too about another aspect of the radiation environment out there is that you do have problem with the viability of both food and medicine, I guess, over time. So we have to think through all of those. And these really are great ways that the moon is helping us prepare for Mars. So,
for sure, food. No, I like to complement what you just said. For sure, food is a key issue, obviously, by human nature. And so I think that it's also important to look at the moon as the proper place when we can validate our capabilities to develop a small greenhouse, not obviously to meet all the nutrition requirements, but to complement what we can be brought from Earth, and also really to give a focus to the people living there that we can grow life. Right. And this is an activity that we carry on in our company. We had a recent experiment at the South Pole, where we, during the local winter, we managed to sustain with the production from a greenhouse the crew there. So I think that food, we learned that from The Martian. Joe, you remember that the book, The Martian, went out precisely, the presentation was given how many years ago? 3-4 years, no, maybe maybe 5 years ago,
Yes,
in
maybe
Washington.
5.
Precisely during the Humans to Mars conference. I remember that precisely. And I lost the count of the years, but this is to say that we learn how important can be. Logistic is a must for sure, but it's really important also to develop somehow a self-sustaining capabilities to grow food on the spot there. And where is there? There is currently on board the space station. There will soon be on board the Gateway. There will super soon be on the moon surface, and in a super near future, Mars transit and Mars surface. So we build again this chain.
That's fantastic. Well, I can't believe it's been, our time is almost up. It's gone so quickly, but it's been a wonderful chance to chat with you all. And let me just offer each of you, Chad, I'll start with you, a last word.
Again, I appreciate the opportunity to be part of the panel and to sort of hear everyone's thoughts. And it seems like, everyone, it's an exciting time, to Maria's point, working together with the Thales Alenia, building the Halo, actually seeing pictures of the hardware and so forth. It's always awesome. Always great to see the flight hardware coming together. Knowing that we've got a launch goal set out on the manifest to actually put Halo and get the gateway up and running. So really exciting times, and looking forward to putting those first boot prints back on the moon again. So looking very forward to it all.
Okay, Sato-san from Japan.
Okay, yes, thank you very much for inviting me. And we are very exciting about the moon mission and also the future Mars mission. And I presented many ideas or many possible contributions from Japan, but as possible roles. But basically, we cannot do them all. So I believe the international collaboration is always very important. So for the moon exploration, we'd like to foster our international partnership to the human Mars mission. Thank you very much.
Thank you. And finally, Maria.
Joe, what can I say to conclude? It's always a pleasure being involved in the activities of Human to Mars. For many years, I've been the representative of the internationals. You remember, Joe, when we were discussing our common plans to go to Mars. Well, we are carrying on all together important steps to meet this objective, and the current journey will bring us together in orbit around the moon and on the moon. But we all know that it's a common intention to reach out Mars, and all together, as Sato-san and Chad and yourself mentioned before, all together we can make it. So international cooperation as the key to open the door, I would say.
That's a fantastic way to end it. And the only thing I would add to all of that is I hope that when we meet again next time in 22, maybe we can do it face-to-face instead of through the virtual means. But it's been a real pleasure. I want to thank you all once again. And I'll turn it back over to you, Wade.